Okay, thank you all to inviting me here for today to proceed with our lesson of chemistry. But before proceeding, let me provide much thanks to God who provided energy for me to exist here in order to exhaust what I have to my learners. Not only but also welcome my learners from Uganda, welcome my learners from Tanzania, welcome my learners from Kenya, as well as my learners from around the world who follow my lessons of chemistry. So you are warmly welcome to participate in my lessons. I think you do not regret to participate in these lessons. But today we are proceeding with our topic which we call the formula bonding and nomenclature, particularly in the part which we call the calculation based on oxidation states. Calculation based on oxidation states. Calculation based on oxidation states. We are supposed to know the concept of oxidation stating, so as when we are dealing with the calculation based on the oxidation stating, we are familiar with it. Oxidation state is the number which tells us the number of electrons in which a particular element has lost, gained, or shared on forming compounds. Oxidation state, also known as oxidation number. But this oxidation state sometimes can be neutral or charged. On the other hand, you can say that oxidation state can be assigned as either neutral or charged compounds or elements. Due to this fact, we have charged oxidation state and neutral oxidation state, as well as we have the compound which are charged compounds, as well as we have a neutral compound. But when I'm talking about the charged compound, means that either positive or negative, we are talking about the compound which needed to undergo the stable state configuration by either gaining electron or losing electron or sharing of an electrons or sharing electrons. So here let us see the concept of how oxidation state can be negative or positive, as well as how it becomes zero. Oxidation state can become zero when the compound or element itself undergoes the stable state configuration. But a compound or element can be positive or negative charged if it needs either to gain electron or to lose electron in order to undergo the stable state configuration. But the concept, we have the concept which causes the electron to lose electron or to gain electron, which we call reduction and oxidation. Reduction is a chemical reaction that involves the gain of electron during chemical reaction. In shorthand, we can say that reduction is gain of electron. Reduction is gain of electrons. A mnemonic device which can be very helpful for you to understand or to recall the concept of oxidation states, particularly in reduction. We can use the letter regen, meaning that reduction is gain of electrons. So reduction is gain of an electron. That is a shorthand on how to remember or on how to know the concept of the reduction. Not only but also let us pass through the concept of oxidation. Oxidation is the chemical reaction that involves the loss of electron during the chemical reaction. On shorthand, you can say that oxidation is the loss of electrons. Oxidation is the loss of electrons. In shorthand, or to get a mnemonic device which can be helpful for you in order to remember or to understand or to distinguish between oxidation and reduction, that we can use oil, in which in the oil oxidation is the loss of electron. That is very simple on how to recall. But there are some reactions which involve both oxidation and reduction states at the same time. That reaction we call it redox. So redox is a chemical reaction that involves the gain of electron and the loss of electron simultaneous or at the same time. In that during the chemical reaction, a species gain and lose electron at the same time. That we call it redox. Let us consider the example here, which can let us consider an example here, which can help us to know the concept of the on how to calculate. Calculate the oxidation state. Up to here, let us see how how we can deal with the question, or how we can do the operation of the question, which maybe the concept of oxidation state is best. Up to here, let us see the concept on how to deal with the calculation based on the oxidation state. So let us see the question here, in which we can use it as an example. So calculate the oxidation state. Calculation the oxidation state of chlorine and sulfur, chlorine and sulfur in the given compound respectively, in the given compounds respectively, in which that compound is potassium chloride, and in the next compound is sulfate, radical of sulfate. So here let us see how to deal with it. To deal with it, let us deal with it separate. To deal with it, let us dig in, see how it is. Is it again to see how it is? So here we have potassium chloride. Potassium chloride. Suppose you know that if it's a charged or potassium chloride is charged or uncharged compound, so here it will become zero. Why it becomes zero? It becomes zero because this is uncharged compound, means that if potassium chloride is uncharged compound, means that itself will be undergo the stable state configuration. So we are supposed to find out here on how to see what number of chlorine used in terms of the loose organ of electrons during forming compounds. So let us begin to see how it is. So here when you consider here we have potassium chloride. So potassium have positive 1 valence plus chlorine here. We are plusing chlorine here plus oxygen, which have negative 2 times 3 is equal to 0. So let us dig in to see how it is. So here chlorine plus 1 positive 1 plus negative 6 is equal to 0. Plus negative 6 is equal to 0. So here chlorine plus 1 minus 6 is equal to 0. So here we have when we collect that term here, we have Cl plus negative 5 is equal to 0. After getting this is equal to 0, let us proceed. So chlorine minus positive times negative is equal to negative. Minus 5 is equal to 0. So to correct the left term here, you will correct the left term here. Chlorine it become chlorine minus 5 plus 5 is equal to 0 plus 5. So chlorine here is equal to 5 positive, is equal to 5. So the oxidation number of chlorine here is equal to positive 5. Is equal to positive 5. So is equal to positive 5. So knowing that, let us deal with the oxidation state of that of potassium. Let us find out the oxidation state as example number 2 of sulfate, which this sulfate is a charged compound. Let us see how it is. So here the answer is this one. So let us see how to deal with let us see how to deal up to here let us deal with the to find sulfur. we have sulfate here with -2, meaning that this is a charged compound. If this is a charged compound, the oxidation state before the charge is -2. So here we have sulfate with -2, meaning that this is the charged compound. If it is a charged compound, the charge is -2. If it is -2, let's dig in. What we are supposed to find out is sulfur. So here we'll take sulfur plus charges of oxygen is -2. -2 times how many oxygen have? 4 oxygen is equal to -2. So here we have a sulfur plus -80 is equal to -2. So sulfur minus 80 is equal to -2. Here we find out the oxidation state of sulfur in the sulfate, in the radical sulfate. So sulfur minus 80 plus 80 is equal to -2 plus 80. Here we are doing the collecting of the lactane. So sulfur is equal to so sulfur is equal to positive 6. So the oxidation state of sulfur is equal to positive 6. This is how to deal with the calculation based on the oxidation state, and how to find out the oxidation state of the given compound or given element. That is how it is. So up to here, let me say thank you my learners from Ghana, thank you my learners from Tanzania, thank you my learners from Kenya, as well as members of this class who participate in these lessons, particularly in the part of the formula bonded nomenclature, which call it calculation based on the oxidation state of given compound. Up to here, let me say thank you, bye bye, enjoy chemistry.